Okay, guys. So we have seen how to deal with objects which are connected to each other by strings, and now I want to discuss today what happens when objects are moving such that they are in contact with surfaces. So just like strings, they provide constraints. Surfaces also provide constraints, some of which we have seen before, but now I really want to generalize it. I want to uh, construct a method which is applicable for all types of surfaces. So, what have we seen up till now? We have seen up till now the fact that if there is a block kept on the floor, if there is a block which is kept on the floor, then when this block is pushed, except for the case when the block is picked up, let's say that we are not discussing that case. Let's say that the block moves such that it is always in contact with this surface. In this case, we know that the acceleration of the block will always be horizontal. वो horizontally कहाँ होगा, that is a separate issue. वो horizontally जो भी नेट फोर्स का डायरेक्शन होगा वहाँ होगा, लेकिन ये श्योर है कि अगर ब्लॉक और फ्लोर का कांटेक्ट हमेशा बना रह रहा है तो ये ब्लॉक का एक्सेलरेशन हॉरिजॉन्टल होएगा, राइट? So I just want to write this. If the block is always in contact with the floor, then it is guaranteed, okay, then the acceleration of the block must be horizontal. And of course, I am assuming that the floor is also horizontal. Now, this may seem like a very obvious statement. This may seem like a very obvious statement. हाँ ये तो होएगा ही ये तो. But I want to be more specific. हम बोलना क्या चाह रहे हैं, right? तो इसके लिए what I do is I draw the normal reaction on the block. And this is the normal reaction which has been applied by the surface, by the floor on the block. And according to Newton's third law, the block will apply a normal reaction on the surface like this. These forces are equal in magnitude and opposite in direction, right? Look at the acceleration. Okay? The green arrow is representative. Green arrow जो है वो left भी हो सकती थी, मैंने right बना दिया है. Green arrow उस plane में कहीं भी हो सकती है, जो floor का जो plane है वहाँ पे कहीं भी हो सकती है. So if you look at the direction of normal reaction and the direction of acceleration, remember that I'm telling you that the acceleration must be horizontal. What is the relationship? What is the thing that we see which is true between normal reaction and this acceleration? क्या है relationship normal reaction or acceleration? What is or what will always be the relationship between the direction of normal reaction and the direction of acceleration? क्या होगा? Yes, 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 yes. So normal reaction is perpendicular to acceleration, right? Normal reaction is perpendicular to acceleration. Or I want to express this in a different way. I want to express this in a different language, right? And the way that I express this, please notice, the way that I express this is that if the surface of the block is always in contact with the floor, please notice that ये जो स्टेटमेंट मैंने लिखा है और ये जो स्टेटमेंट मैंने लिखा है बिल्कुल सेम है, राइट? अब मैं ये जो सेकेंड पार्ट है, अगर अगर ये गिवन है कि ब्लॉक फ्लोर के कांटेक्ट में रहता है, तो second part of the statement that I said previously was that the acceleration of the block must be horizontal. But now I want to put it in different terms. So if the surface of the block is always in contact with the floor, right, then the acceleration of both surfaces along normal reaction, along the direction of normal reaction, or perpendicular to surfaces must be same. So how is this statement and this statement, how are these two statements different from each other, and how are these two statements the same as each other? Because मैंने तो same लिखा है, मतलब उनका जो मीनिंग है, उनका वो जो इसका जो कंक्लूजन है वो सेम है, बट ऑब्वियसली डिफरेंट वर्ड्स में लिखा गया है, राइट? सो व्हाट इज different between the statement 1 that I have underlined in yellow and the statement 2 that I have underlined in yellow? So statement 1 is basically something which has been said which is obvious, right? Block contact में है floor के साथ, right? The block is in contact with the floor and therefore the block must move, therefore the block must move horizontally, right? अगर फ्लोर के साथ कांटेक्ट में नहीं रहेगा ब्लॉक, तो ये पॉसिबल है कि ये ब्लॉक ऊपर चला जाएगा, राइट? ब्लॉक की कोई बंदा आके इसको जो है ऊपर पिकअप कर लेगा ब्लॉक। बट अगर ब्लॉक को पिकअप कर लिया तो कांटेक्ट ही खत्म हो गया, और मेरा ये इनिशियल स्टेटमेंट है, इट इज गिवन टू यू that the block and the floor always remain in contact with each other. If the block and the floor always remain in contact with each other, then this simply means that the acceleration of the block must be horizontal, right? ये I hope सबको समझ में आया है। अब मैंने इसको अलग तरीके से लिखा है. Let's understand the second statement. Okay? Let's understand the second statement. So in the second statement, I'm saying that look, if it is given that the block and the floor always remain in contact with each other, if it is given that the block and the floor always remain in contact with each other, then the acceleration of the block and the floor perpendicular to the interacting surfaces or along the normal reaction must be same. So let's look at the floor. Okay? Let's look at the floor. So the statement says that if the floor and the block remain in contact with each other, that means that these 2 points remain in contact with each other. Right? मैंने 2 dots बनाए हैं वहाँ पे. अगर ये दोनों पॉइंट्स कांटेक्ट में रहेंगे हमेशा, तो इन दोनों पॉइंट्स का एक्सेलरेशन इस डायरेक्शन में हमेशा सेम रहेगा. राइट? इट्स लाइक you are moving, you stick one hand onto the other hand. मतलब जैसे ताली बजाते हैं तो आप अपना दोनों हाथ जैसे नमस्ते करते हैं, आप दोनों हाथ जोड़ लो. If you join the palms of your hands and if you ensure that the palms of your hands are always joined and you move your arms around, right, then the acceleration of the hands perpendicular to the surfaces, perpendicular to the interacting surfaces, must remain the same. So, अगर ये point 1 है और ये point 2 है, then acceleration of point 1 in the vertical direction must be equal to acceleration of point 2 in the vertical direction. अगर acceleration of point 1 acceleration of point 2 से ज्यादा हो गया vertical direction, horizontal से मुझे कोई मतलब ही नहीं. अगर acceleration of point 1 acceleration of point 2 से ज्यादा हो गया, अगर acceleration of point 1 acceleration of point 2 से ज्यादा हो गया ऊपर की तरफ, तो क्या हो जाएगा? The block would lose contact with the floor, right? और अगर point 2 का acceleration ऊपर की तरफ ज्यादा हो गया, तब क्या हो जाएगा? अगर point 2 का acceleration ऊपर की तरफ ज्यादा हो गया point 1 से, तब ये block floor के अंदर धंस जाएगा, right? It will actually go inside the floor, which again is not allowed, right? So contact छूट गया, ये भी allowed नहीं है. Contact है और एक बॉडी दूसरे बॉडी के अंदर घुस गई, ये भी अलाउड नहीं है. Therefore, the acceleration of the 2 points must be same. I want you to do an experiment. Okay, I want you to do an experiment. So take a pen and keep it in your hand and keep your hand horizontal. Right, so the palm of your hand must be horizontal, right? और आपने उस पे पेन रखा हुआ है, राइट हैंड में करना है. तो राइट हैंड में palm मेरा facing the ceiling है. The palm is facing the ceiling, the back of the hand is facing the floor, and I have kept a pen in my hand. Okay, now I want to move my hand any which ways I want, but the pen must not lose contact with my hand. Okay? I can move my hand any which way I want. गोल गोल घुमा दिया, लेफ्ट राइट कर दिया, ऊपर नीचे कर दिया. But the pen must not lose contact with my hand. Right? In this case, जो है हाथ में पेन को रख के हाथ हिलाना है. रिपीट क्या करना है उसमें? मैंने कौन सा टेक्निकल बात करी? If you have your pen or some heavy object in the right hand and your right hand is flat, palm of your hand is facing up towards the ceiling, then if you move your hand any which way that you want, keeping the pen or the object in contact with your hand, then it is guaranteed that the acceleration of the object and the acceleration of your hand perpendicular to the interacting surfaces. That means that if you keep your hand always horizontal, then the acceleration of your hand and the acceleration of the object that you've kept on your hand, vertical acceleration of your hand, vertical acceleration of that object is always the same. Now what you can do is you can take your hand up and then uske baad se you can bring your hand down, but now try to lose contact with the pen. तो आप अपना हाथ ऊपर ले गए और आप अपना हाथ बहुत तेजी से नीचे लेके आए, such that your hand loses contact with the pen. What has happened? Well, the acceleration of your hand and the acceleration of the pen vertically downwards now have different values. The acceleration of your hand is greater than the acceleration of the pen in the downward direction, and therefore the contact is lost. Okay? दूसरा केस अपन डिस्कस नहीं करना चाहते हैं क्योंकि आपको फिर हॉस्पिटल जाना पड़ेगा अगर पेन आपके हाथ के अंदर घुस गया तो, right? So the acceleration of two surfaces which always are in contact with each other must be the same in a direction which is perpendicular to the surfaces. So in this case, since A2 is equal to the acceleration of the floor, which we know is equal to 0, this implies that A1 in the vertical direction must be equal to 0, and therefore the block can only have horizontal acceleration. Right? This is the logic behind the statement. Point 1 or point 2 का acceleration perpendicular to the surface must be same. नहीं तो दो चीजें हो जाएंगी, दो चीजें हो सकती हैं, या तो point 1 और point 2 ब्लॉक और फ्लोर का कांटेक्ट छूट जाएगा, कांटेक्ट खत्म हो जाएगा, which is not possible because I'm telling you that they always remain in contact. और point 1 और point 2 के acceleration different होने से, vertical acceleration different होने से ये block floor के अंदर घुस जाएगा, which is also something which is not allowed, right? So therefore the only thing which is possible is that the vertical acceleration of point 1 and point 2, they remain the same. Now, since point 2 is a point on the floor, we know that, or at least here we know that point 2 will have no vertical acceleration. Therefore, point 1 cannot have any vertical acceleration. And therefore, the acceleration of the block can only be horizontal. Okay? हाँ भाई, कुछ बताओ।
सर आप चैट पे हाई लिख सकते हो, सर दिखा नहीं रहा है आपका नाम।
क्या क्या हुआ?
आप चैट पे हाई लिख सकते हो, दिखा नहीं रहा है आपका नाम।
अच्छा अच्छा, ओके ओके। Is it obvious that acceleration need to be same between surface and acceleration? भाई आप स्मिथ अपने हाथ में पेन लीजिए और पेन को try to move your hand while keeping the pen on your hand. Right? You will find that the surfaces in contact always remain in contact. If they remain in contact, then the acceleration of the two surfaces perpendicular to the surfaces must be same. तो इसमें ऑब्वियस क्या है और अनऑब्वियस क्या है ये तो मुझे नहीं मालूम है, लेकिन मेरे को ये समझ में आ रहा है कि अगर पॉइंट 1 और पॉइंट 2 जो मैंने यहाँ बनाया है इनके वर्टिकल एक्सेलरेशंस डिफरेंट हो गए, either of two things will happen. One, contact will be lost. Two, object 1 will go inside object 2, and both are not allowed. Therefore, their accelerations perpendicular to the surface must remain constant. Okay, so now we want to take this. Now we want to take this one step further. Okay? We want to take this one step further. So supposing that we have an inclined plane. This is again something that you have already seen, something that you already know. And this inclined plane is fixed. And we have a block which is kept on the inclined plane. So what I will do is I will consider a point 1 on the block and I will consider a point 2 on the inclined plane, right? These are the two objects which are in contact with each other. So I have taken point 1 and point 2 here. So my statement says that if the two surfaces are in contact, then acceleration of both surfaces along the normal reaction or perpendicular to the surface must be same. This means that the acceleration of point 1 and point 2 in this direction must be same. Okay? The acceleration of point 1 and point 2 along the yellow line must be same. Right? Please do not get confused with this. This is the reason why I took so much time to teach you vectors. Okay? So acceleration that you have seen up till now are horizontal and vertical. They do not have to be. They can be in any direction. So here the acceleration of points 1 and 2 along the yellow line must be same. Okay, according to our statement. अगर 1 का acceleration इस yellow line के along नीचे की तरफ 2 के acceleration से ज़्यादा हो गया तो ये block इस inclined plane के अंदर घुस जाएगा, और अगर point 2 का acceleration ज़्यादा हो गया तो इन दोनों के बीच में separation हो जाएगा, right? Both things are not allowed. So the acceleration of point 1 and 2 along the yellow line must be 0. Now, since since the inclined plane is fixed, since the inclined plane is fixed, so since the inclined plane is fixed, therefore acceleration of point 2 in this direction is equal to 0. In fact, in any direction it is equal to 0. But I am interested in only this yellow wala direction. Fixed है तो हर direction में 0 acceleration, but I am only interested in the yellow direction. This means that the acceleration of point 1, therefore acceleration of point 1 along this yellow direction must also be equal to 0. That means that the block जिसका कॉन्स्टिट्यूएंट पॉइंट 1 है, पॉइंट 1 उस ब्लॉक के ऊपर लाई करता है, अंदर लाई करता है. This means that the block can only have an acceleration along this direction, right? And that is what we concluded, I think, the last time that we discussed this, that if I leave the block on the fixed inclined plane, then the only thing that is going to happen, remember there is no friction, then the only thing that is going to happen is that this block is going to slide down. It is going to slide down the inclined plane. So as long as I ensure that the block always remains in contact with the inclined plane, the acceleration of the block must be along the inclined plane. And the reason is that perpendicular to the inclined plane, the acceleration of the inclined plane is zero, and therefore perpendicular to the inclined plane, the acceleration of the block must also be zero. Okay, right? I hope everybody is understanding this. अगर पॉइंट 1 और पॉइंट 2 का एक्सेलरेशन में मिसमैच हुआ along the yellow line, तो या तो कांटेक्ट खत्म हो जाएगा या ये दोनों एक दूसरे के अंदर घुस जाएंगे. Both are not allowed. Therefore, along the yellow line, the acceleration of the two blocks or the two objects in contact must be the same, right? And therefore, acceleration of point 2 along the yellow line is 0 because it is fixed, and therefore acceleration of point 1 or acceleration of the block along the yellow line must also be 0. Therefore, point 1 or the block can only have an acceleration perpendicular to the yellow line. That means that it can only have an acceleration along the surface of the inclined plane. Okay? या समझ में? मतलब मैं क्या कर रहा हूँ, मैं एक ऑब्वियस चीज को थोड़ा सा घुमा फिरा के बोल रहा हूँ, और इस घुमाने फिराने का रीजन ये है कि अभी हमको जो प्रॉब्लम्स देखनी है, जो हमारे सामने आएंगी, उसमें ये चीज यूज करना है. whatever I'm teaching you now, whatever I'm telling you now. Okay, so this is all about when things are fixed. What about when things are moving? Then what happens? Then how does the objects in contact, how do the objects in contact move? Well, let's take an example. So we have a sphere like this, and we have an inclined plane like this, and we have an inclined plane like this. Okay, let this be inclined plane 1, let this be inclined plane 2, let this be 30 degrees, let this be 45 degrees. Now I am going to move this inclined plane with an acceleration of 2 meter per second square. Okay, and I'm going to move this guy, this inclined plane, with an acceleration of 1 meter per second square. And I can now ask, find acceleration of sphere. Right? I can now say, find acceleration of the sphere. Please notice that मेरे को कोई फोर्स नहीं दिया, मास नहीं दिया है, फोर्स नहीं दिया, कुछ नहीं दिया. मेरे को केवल ये बोला है कि find acceleration of the sphere if it is always in contact with the two wedges, right? ये दो wedges से अगर ये हमेशा कांटेक्ट में रहता है तो स्फीयर का एक्सेलरेशन क्या होगा? And please notice that they have not provided us with mass or forces. This means that the acceleration of the sphere will be a consequence of the geometry of the system. Acceleration of the sphere is decided because of the fact that it is moving in contact with these two surfaces. Okay? So now you need to follow me very carefully. Question number 1. Yeah, I'm going to ask you a series of questions and you're going to answer me. Question number 1. How many surfaces is the sphere in contact with? How many surfaces is the sphere in contact with? Right? Okay. तो इसमें किसी को कोई प्रॉब्लम नहीं है, किसी को कोई प्रॉब्लम नहीं है? बताओ भाई. सोहम, तनिषा, विवान, किसी को कोई प्रॉब्लम नहीं है? दिस इज अंडरस्टूड. काव्या, ऋषि, सुदीप, दिशा. What are the two surfaces? What are the two surfaces? What are the two surfaces? So let me again ask you the second question. हाँ बिल्कुल सही. Number 2. Number 2. Great. Yes. Yes. What are the two surfaces? Or I can ask, ये surfaces belong to what? Right? The surfaces that we are talking about belong to what? And the answer is, of course, they belong to the two inclined planes. Surfaces of the two inclined planes, right? So let me take this one by one. Third, if we take sphere and right inclined plane, please notice the question. Okay, you have to answer this question. If we take the sphere and the right inclined plane, then the acceleration of sphere and acceleration of inclined plane must be same in which direction? Read the question. Very good, Paul. Yes. If we take the sphere and I will draw it here for you. I will draw it here for you. This is the sphere, and this is the incline. And I have told you that the incline is moving like this. Moving का मतलब भी नहीं है, motion तो बाद में देखना है. So if we take the sphere on the right and the right incline, then acceleration of the sphere and acceleration of the inclined plane must be the same in which direction? They must be the same in which direction? बताओ भाई, फिर सब लोग शांत हो गए. त्रिश, मनीष, मनीष कहाँ गया? आकाश, सुदीप भाई, चारूवी फिर शांत हो गई. किस डायरेक्शन में सेम रहना चाहिए? ऑपोजिट. ऑपोजिट शौनक कौन सा होता है? अपवर्ड. क्यों भाई राधिका, अपवर्ड क्यों सेम होना चाहिए? हाँ, तो जब भी ऐसा मैं क्वेश्चन पूछूंगा, हाँ, देखो देखो, जब भी मैं ऐसा क्वेश्चन पूछूंगा तो आपको क्या करना है, या जब भी ऐसा क्वेश्चन आपके सामने आएगा, एक पॉइंट आपको बनाना है स्फीयर पे और एक पॉइंट आपको बनाना है वेज, राइट? जहां पे भी वो कांटेक्ट में है, वेरेवर देयर इज कांटेक्ट. नहीं चिराग, ऐसा नहीं हो सकता है ना, एनी डायरेक्शन नहीं हो सकता. जहां पे भी वो कांटेक्ट में है, एक डॉट आप बनाओ एक सरफेस पे, एक डॉट बनाओ दूसरे सरफेस पे, और दोनों डॉट्स को ज्वाइन कर दो. Wherever they are in contact with each other, draw a dot on the surface 1, draw a dot on the surface 2, and join the two dots. जो भी लाइन बनेगी, हाँ शिवेन इंडिपेंडेंट है, जो भी लाइन बनेगी, राइट, that will be the direction in which acceleration must be same. आप देख लो, मैंने यही काम किया है. यहाँ पे मैंने ये वाली लाइन बनाई, ये 1 ये 2 लाइन बना दो ऐसे. इस डायरेक्शन में एक्सेलरेशन दोनों सरफेस का सेम रहना चाहिए. यहाँ पे देखिए 1 एंड 2, इस डायरेक्शन में दोनों का एक्सेलरेशन सेम रहना चाहिए. अब इस डायरेक्शन में फिक्स्ड इंक्लाइन प्लेन का एक्सेलरेशन 0 है, तो ब्लॉक का भी इस डायरेक्शन में एक्सेलरेशन 0 होना चाहिए. So I will ask the question again. If we take the sphere and the right inclined plane, then acceleration of the sphere and acceleration of the inclined plane must be the same in which direction? Horizontal. Okay? Very, very simple. So I will just write this down. Draw a dot on each object at the point of contact and connect by a line. Okay, so the acceleration of the wedge along this direction and the acceleration of the sphere along this direction must be same. तो wedge का acceleration क्या दिया है? wedge का acceleration क्या दिया है? horizontal direction तो given है हमें. wedge का acceleration तो 2 मीटर पर सेकेंड है लेफ्ट की तरफ. वेज का एक्सेलरेशन तो 2 मीटर पर सेकेंड है लेफ्ट की तरफ. इसका मतलब ये हुआ इसका एक्सेलरेशन अगर 2 मीटर पर सेकेंड स्क्वायर है लेफ्ट की तरफ, तो ये स्फीयर का एक्सेलरेशन भी 2 मीटर पर सेकेंड स्क्वायर होगा लेफ्ट, राइट। अगर इंक्लाइंड प्लेन का एक्सेलरेशन टुवर्ड्स द लेफ्ट इज 2 मीटर पर सेकेंड स्क्वायर, नहीं, दो पॉइंट ऑफ कांटेक्ट नहीं होंगे, दिस विल नेवर हैपन in our physics that we are learning. That's a very good question. It will never happen that there are two separate points of contact. Okay? If there are multiple points of contact, all of them will behave in the same way. जो आप क्वेश्चन पूछ रहे हो वो फिर हम रिजिड बॉडी डायनेमिक्स में आ गए, वहां पे रोटेशन पोटेशन होने लग जाएगा। रिमेंबर दैट वी आर ओनली टॉकिंग अबाउट पॉइंट ऑब्जेक्ट्स, इररिस्पेक्टिव ऑफ द फैक्ट कि मैंने स्फीयर लिख दिया, मैंने वेज लिख दिया, मैंने टेबल लिख दिया, चेयर लिख दिया। We are all talking about point objects. Okay. हाँ. Okay. Number 4. Question number 4. If we take the sphere and the left incline, then acceleration must be same in which direction? All you have to do is now draw that yellow line and that's it. और कुछ नहीं करना है, और कुछ नहीं करना। If the wedge is moving in the right direction, then what will happen? तो इस केस में चेतल द स्फीयर, अभी जो मैंने लेफ्ट वाला 2 मीटर पर सेकेंड स्क्वायर लिखा है वो 2 मीटर पर सेकेंड स्क्वायर राइट में लिखना पड़ेगा, ठीक है ना। एक मिनट होल्ड, एक मिनट। हाँ सॉरी, तो अनीश अभी आंसर मैं बता रहा हूँ, आई डोंट नो द आंसर। So, what is the answer to this question, Filal? If we take the sphere on the left incline, then acceleration must be the same in which direction? It must be the same in. It must be the same in. हाँ, very good अभिजीत, yes. तो हमारे पास ये incline है, हमारे पास ये sphere है, और मैंने इसमें 0.1 बनाया, इसमें 0.2 बनाया, इस डायरेक्शन में एक्सेलरेशन सेम रहना चाहिए, ठीक है। अब थोड़ा वेक्टर्स का काम आएगा। इसका एक्सेलरेशन आई हैव गिवन एज 1 मीटर पर सेकेंड स्क्वायर, इसका एक्सेलरेशन आई हैव गिवन एज 1 मीटर पर सेकेंड स्क्वायर। इसका एक्सेलरेशन मेरे को मालूम है कि हॉरिजॉन्टल कंपोनेंट 2 मीटर पर सेकेंड स्क्वायर, ठीक है ना. नाउ प्लीज सी व्हाट आई एम गोइंग टू डू. Anybody has an idea what I'm going to do now? Anybody willing to guess what I'm going to do now? Anybody willing to guess? हाँ, कंपोनेंट्स तो निकालने पड़ेंगे. हाँ,
सर कंपोनेंट्स को उसी येलो लाइन, दोनों वो येलो लाइन पे दो कंपोनेंट्स निकाल के उनको इक्वेट कर दें.
नहीं 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 नहीं, कंपोनेंट निकालने से पहले कुछ करना पड़ेगा. कंपोनेंट निकालने से पहले कुछ करना पड़ेगा. कैन एनीबडी गेस व्हाट आई एम गोइंग टू डू? कंपोनेंट निकालने से पहले. नहीं, रिलेटिव मत वर्ड यूज किया करो, मुझे डर लगता है रिलेटिव वर्ड्स. नहीं, एडिशन नहीं करेंगे. We will assume. नहीं, एफबीडी नहीं बनाना हो गया. We will assume that this sphere has an additional acceleration a vertically. Yes, yes, we have to assume that this sphere has an additional acceleration a vertically. क्योंकि जो ये क्वेश्चन मेरे को दिया है उसमें मुझे तो नहीं बताया है कि ये हॉरिजॉन्टल मूव करेगा या वर्टिकली मूव करेगा, कैसे मूव करेगा. सो आई विल अस्यूम that the acceleration of this sphere has an x component of ax and a y component of ay. Remember, when the rain was falling, then uh, then uh, the velocity of the rain was given by xi cap plus yj cap. Okay? In the same way, the acceleration of this sphere is assumed to be having a component along the x-axis and a component along the y-axis, right? Okay. अब जो x-axis वाला component है वो तो मैंने यहाँ वर्कआउट कर दिया. जो x-axis वाला component है वो तो मैंने यहाँ वर्कआउट कर लिया. अब मैं यहाँ पे आया दूसरे उसके लिए. तो दूसरे के लिए मेरे को y कंपोनेंट की वैल्यू कुछ तो अज्यूम करनी पड़ेगी. मैंने a अज्यूम कर ली है क्योंकि मेरे को x कंपोनेंट पहले से मालूम है. नाउ लुक एट दिस. This is the line along which the acceleration must be the same. The wedge, the inclined plane, has an acceleration of 1 meter per second square in this direction, and the sphere has an acceleration of 2 meter per second square and a in this direction. Okay. Now I know that since this is normal to the inclined plane, therefore the angle made with the vertical must be the same as the inclined plane. So this angle must be 30 degrees. And if this angle is 30 degrees, this must be 60 degrees. This must be 60 degrees. So let's find the component of 1 along this line. Perpendicular to this line, कोई मतलब नहीं मेरे को. Along this line मतलब है मेरे को. So 1 का आएगा 1 into cosine of 60 degrees. So this is what? This is the component of velocity of, sorry, acceleration. This is the component of acceleration of inclined plane along the perpendicular, along the yellow line. हाँ, एक सेकंड. हाँ होएगा ना, करो इसको आगे करो। हाँ भाई सॉरी। सो हाँ रुको, मैं निकाल के दिखा रहा हूँ। So this is the component of acceleration of the incline along yellow line, and this must be equal to the component of acceleration of the sphere along yellow line, right? So this you must be clear about. So this must be equal to the component of acceleration of sphere along yellow line. What is the component of acceleration of the sphere along yellow line? What is the component of acceleration of the sphere along yellow line? Well, it is ये 2 मीटर पर सेकेंड स्क्वायर का तो 2 cos 60 आ रहा है इधर, लेकिन ये आ रहा है a cos 30 ऊपर की तरफ, राइट? Very good. Yes, Parth. Very good. Yes. So this guy will be equal to 2 cosine 60 minus a cosine 30, and this guy will be equal to 1 cosine 60, and they must be equal to each other. So therefore we get cos 60 is equal to 2 cos 60 minus a cos 30. cos 60 कितना होता है? हाफ होता है ना, हाफ इज इक्वल टू 1 माइनस a रूट 3 बाई 2। हाँ कितना आ रहा है? a का वैल्यू कितना आएगा? a का वैल्यू 1 बाई रूट 3 आएगा। सही लिखा मैंने? हाँ पूछो, डाउट पूछो। अनम्यूट करो चैट पे। नहीं 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 नहीं, देखो देखो, ना 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 ना, ये डाउट बिल्कुल सही है और आना नहीं चाहिए। सो व्हाट द, हाँ, व्हाट द डाउट इज, द डाउट इज ये 1 cos 60 प्लस 2 cos 60 होना चाहिए, क्योंकि सेम डायरेक्शन है, राइट। ये डाउट हमारे मन में नहीं आना चाहिए, और इसका मैं रीजन बता रहा हूँ। इसका रीजन ये है कि मैंने जो डिफरेंट कलर्स यूज किए हैं वो एक पर्पस के लिए यूज किए। सो आई वांट टू टेल यू दैट लुक, these two diagrams are separated from each other. This part is dealing with acceleration of the incline, and the other part is dealing with the acceleration of the sphere. That is why the components of acceleration of the sphere I have written in green, and the components of acceleration of the incline I have written in red. So the acceleration of the sphere along the yellow line must be the sum of components of acceleration which I have already drawn along the yellow line. तो ये जो रेड एरो बनाया है मैंने, this is the acceleration of the inclined along the yellow line, और ये जो मैंने ग्रीन वाला जो बनाया है, ये जो मैंने ग्रीन बनाया है, this is the acceleration of the sphere along the yellow line. अब इसमें दूसरा डाउट क्या आ सकता है, ये a cos 30 माइनस 2 cos 60 क्यों नहीं लिया? अगर मैंने a cos 30 माइनस 2 cos 60 ले लिया तो स्फीयर का एक्सेलरेशन अलोंग द येलो लाइन किधर हो गया? स्फीयर का एक्सेलरेशन अलोंग द येलो लाइन किधर हो गया? ऊपर की तरफ हो गया। a cos 30 को मैंने ज्यादा मान लिया, अज्यूम कर लिया ये बड़ा है, तो a cos 30 माइनस 2 cos 60 लेने का मतलब कि स्फीयर का एक्सेलरेशन ऊपर की तरफ हो गया अलोंग द येलो लाइन, और इंक्लाइंड प्लेन का एक्सेलरेशन तो नीचे की तरफ है अलोंग द येलो लाइन। तो ये एक्सेलरेशंस डिफरेंट हो गए। एक्सेलरेशन सेम का मतलब होता है that not only the magnitude must be same, but the direction should also be the same. So I get a is equal to 1 by root 3. This implies that the acceleration of the sphere is इस डायरेक्शन में 1 by root 3। हाँ मैं बता रहा हूँ, एक मिनट। और इस डायरेक्शन में द एक्सेलरेशन इज 2। राइट, नाउ यू कैन फाइंड द नेट एक्सेलरेशन। इसका अंडर रूट करके स्क्वायर करके ऐड कर देना, राइट। 4 + 1/3 रूट 4 + 1/3 है, रूट 13/3। हाँ
सर तो इसमें हमेशा ऐसे जब क्वेश्चन आते हैं तो इसमें हमेशा जो पॉइंट ऑफ कांटेक्ट से जो लाइन जाती है उस पे दो अलग सिस्टम्स अज्यूम करके इक्वेट करना पड़ता है, राइट?
क्या बोल रहा है?
जैसे जैसे सर एक आपने इंक्लाइन का ले लिया और आपने एक स्फीयर का ले लिया और दोनों को
हाँ
इक्वेट किया कंपोनेंट्स ऐड करके।
हाँ
ओके।
हाँ, चलो मैं फिर से बता, I'll do this again. The ball ka mass has got no role to play here. Okay? Mass of the ball has no role to play because हम इसका जो acceleration है वो geometrical consideration से ही fix कर दे रहे हैं. We don't need to know the forces to find the acceleration in this case. Okay? The reason is that constraints की वजह से इसका acceleration fixed हो गया. चलो फिर से देखो. Please see here. Okay, all your attention on the screen. The problem given to me is that the sphere is in contact with two wedges, and the thing is that it remains in contact with the two wedges as it moves. This is the key statement. The sphere is always in contact with these two wedges. Find the acceleration of the sphere. Well, I don't know where the acceleration of the sphere is. I don't know what the acceleration of the sphere is. So I will assume that the acceleration of the sphere has some y component ay and it has some x component ax. Okay, I will assume that the sphere has an acceleration ax I cap plus ay j cap, which is the most general acceleration I can assume. Because I don't know that the sphere will be moving definitely horizontally or definitely vertically, I have assumed that there is an x component and there is a y component. Now, I focus my efforts on the contact surfaces. Pehle right wala inclined and the sphere. So I draw near the point of contact a point on the sphere and a point on the incline, and then I join the two points and I get a straight line. Now, the acceleration of the wedge and the acceleration of the sphere along this yellow line must be the same. So, for my convenience, I draw this yellow line somewhere else and I draw the acceleration of the sphere and I draw the acceleration of the wedge along the yellow line. Please notice, जो perpendicular है yellow line के, उससे मुझे कोई मतलब नहीं है. Okay? तो ये दोनों acceleration same होने चाहिए. दोनों acceleration same होने चाहिए. Right? So since both must be same, not only in magnitude but also in direction, this implies that ax is equal to 2 meter per second square like this. Right? तो ax का जो भी डायरेक्शन मैंने अज्यूम किया है ये गलत है. ax माइनस x के अलावा होना चाहिए. ये मेरे पास कैसे आ रहा है? How am I coming to this conclusion? I am coming to this conclusion because of the fact that both the acceleration of the sphere and the inclined plane along the yellow line must be the same, not only in magnitude but also in direction. Okay. Now let's look at the second condition. Okay. Let's look at the second condition. Draw a dot on the sphere near the point of contact. Draw a dot on the incline near the point of contact. Connect by a yellow line. Draw this yellow line somewhere else. Draw the acceleration of the particle 1 or object 1. Draw the acceleration of the object 2. Okay. Please notice that this step and this step step on the right, step on the left. They are absolutely the same, except for the fact that in the step in the left, I am very, lucky that all the vectors are lying along the line. Okay? I am very lucky that all the vectors are lying along the line. Okay? Right? तो मेरे को कोई दिक्कत नहीं है, लेकिन जब मैंने राइट वाला डायग्राम बनाया, उसमें अनफॉर्चुनेटली जो एक्सेलरेशन वेक्टर्स हैं वो अलोंग द लाइन नहीं है। कोई प्रॉब्लम नहीं, मैं निकालूंगा कंपोनेंट। हाँ बिल्कुल सही राधिका, ax should be along the negative x axis. ax should be along the negative x axis, but I am doing this for the purposes that if you choose to carry out this calculation first, so the component of 1 along this line will be 1 cosine 60, and the component of ax along this line will be ax cosine 60, and the component of ay along this line will be ay cosine of 30. Right? Again, please notice that जो ग्रीन एरो आ गई वो तो ऊपर आ गई और जो रेड एरो है वो नीचे है. This is not possible. This is just not possible. They must be the same not only in magnitude but also in direction. Right? So here then we take the help of the fact that ax is -2. Right? So what we do is we say that I'm going to do it like this. ay sin 60 भी लिख सकते हैं बिल्कुल. Yes. So I will cross this out, since we know that ax is equal to -2. I will draw ax here 2, and I will find the component of 2 here, which will be 2 cosine 60, and I will cancel this out as well. And now, since the accelerations must be the same both in direction and magnitude, so 1 cosine 60 degrees should be equal to 2 cosine 60 degrees minus ay cosine 30 degrees. And again we get the answer ay is equal to 1 by root 3. So ax की वैल्यू ये आई और ay की वैल्यू ये आई, मीटर पर सेकेंड स्क्वायर. So the sphere's acceleration, and I'll write it here, acceleration of this sphere is equal to -2 I cap plus 1 by root 3 j cap meter per second square. I have absolutely no need for application of the second law or the third law or the first law. Purely from geometrical considerations, I can find this out. Prasanna, I can't understand your question. मुझे तेरा क्वेश्चन समझ में नहीं आया. हाँ मैं करवा रहा हूँ ना और एग्जांपल दे रहा हूँ. चल, नाउ योर टर्न. You don't have a lot of time, but जब भी मैं शेडिंग करता हूँ ना इस चैप्टर में कहीं भी, तो शेडिंग का मतलब होता है दैट दीज आर फिक्स सरफेसेस. फ्लोर है, सीलिंग है, वॉल है, उसके लिए मैं शेडिंग करता हूँ. ये ऑब्जेक्ट 1 है, ये ऑब्जेक्ट 2 है, और it is given that this angle is 53 degrees. So इसका acceleration a is equal to 3 meter per second square. Find acceleration of 2. कंडीशन दिया है ना 1 और 2 ऑलवेज इन कांटेक्ट, तो गिवन है ना, मतलब that is 1 and 2, the blocks 1 and 2 always remain in contact with each other. दो डॉट बनाने हैं, येलो लाइन बनानी है, मतलब येलो आप ऑब्वियसली नहीं बनाओगे. फिर एक्सेलरेशन, फिर एक्सेलरेशन के कंपोनेंट्स, मीटर पर सेकेंड स्क्वायर। हाँ हाँ भाई, 0.1 0.2 येलो लाइन के अलोंग एक्सेलरेशन दोनों का सेम होना चाहिए। येलो लाइन के अलोंग एक्सेलरेशन दोनों का सेम होना चाहिए, लेकिन ये तो वॉल है। इसका मतलब कि ऑब्जेक्ट 2 का एक्सेलरेशन केवल वर्टिकली डाउनवर्ड्स हो सकता है। Object 2 cannot have a horizontal acceleration. This was the first thing you were supposed to find out. Then dot dot yellow line. Yellow line. The acceleration of block 1 is 3. The acceleration of block 2 is a। इन दोनों का कंपोनेंट इस डायरेक्शन में सेम होना चाहिए। Now all I need to do is find the angle. The inclined plane है of angle 53 degrees. So this angle must be 53 degrees. And of course this angle must be 37 degrees. So this component is 3 cosine 37 degrees. And this component is a cosine 53 degrees. So 3 cosine 37 degrees must be equal to a cosine 53 degrees. So 3 into cosine 37 कितना होता है? 4/5 is equal to a into 3/5। हाँ प्रसन्ना, बहुत पहले मैंने बताया था ना, इंक्लाइंड प्लेन पे अगर नॉर्मल रिएक्शन है तो वर्टिकल के साथ उसका एंगल वही होता है। याद है या नहीं याद? वही मैंने बोला था ना, कंपोनेंट्स तो फिजिक्स का ब्रेड एंड बटर है, तो याद होना चाहिए। So what you have figured out today are called wedge constraints. I hope you have figured out. We'll do more problems of this on Saturday. एक और चाहिए प्रॉब्लम हो क्या? बट ये मैं अभी डिस्कस नहीं करूंगा, ये मैं नेक्स्ट क्लास में डिस्कस करूंगा। मुझे मालूम नहीं है भाई रजत, ये सब सवाल मुझसे मत पूछा कर, सब मुझे नहीं मालूम रहता है। Find the acceleration of the So you have to find the acceleration of the block, right? तो इसमें थोड़ा बहुत Newton's laws भी लगेगा, okay? And of course, what we have learned that you will apply. Find the acceleration of the ऊपर वाला block. Chalo, so I will leave you now, and we will meet on Saturday. मेरे को नहीं मालूम है वीडी बनाना पड़ेगा नहीं बनाना पड़ेगा बिना न्यूटन्स लॉज के हो जाएगा all up to you. Try and do it. See what happens. Chalo. Okay. Bye bye.